Now, for those that have just joined, I know I was told to help you understand the Kaggle, but I wanted to like have an intro, then I shall go to Kaggle because for me, I usually find it difficult to just start straight to something unless you have some basic overview. So I was saying that the recommender system is a very key thing to understand at this time as a data scientist, because you realize that the recommender systems are applied everywhere. When you go to Netflix, when you go to YouTube, Twitter, when you go to TikTok, the recommender system are applied. Also on these big the e-commerce system like a Jumia or those other platform, you see that the recommender system is being applied to recommend products or stuff to people. So understanding like the concept behind the recommender system is very crucial. It's very crucial and a very good project. You realize that nowadays things are moving towards the direction of AI and automation. So these systems are very to basically recommend a system, as you had learned earlier in the Athena, these are tools designed to provide personalized suggestion to user by by recommending like things and stuff. So we have two types of the recommender system. We have the collaborative filtering, and then we also have the content-based filtering. So in a nutshell, I'm going to describe what these two differ with each other or entails, and then we are going to begin straight. I'm going to share my screen in a few. So the collaborative filtering relies on the preference and behaviors of users to make recommendation. So like this one is based on the user and the items. Like it depends like on the behavior of the users. So for example, the idea is that the user who have agreed in the past will also agree in the future, and also the user will like items similar to what they had like similarly. Like for example, let's say you are watching a series on Netflix. So basically they will recommend something similar to that. Sorry, like at the algorithm in Netflix, it will recommend like video or maybe the movie or a series depending on what you had watched previously. So this one is based on what you had. Uh, is someone trying to talk? Ray? Okay. So so this one recommends item that similar users like. Like for example, let's say most people at the moment, like I know there's a time, or maybe there's a series that is trending. For example, that movie, I remember I think it was in 2023 there or somewhere. There was this series on Wednesday. That series. So you see that most people watched it. So when you go to Netflix, it will be like the first item to appear for you because this one like is based on what many people like watch. So the collaborative, this is based on the user and the item. And then basically you have other subcategories under it, but I'm not going into that for the interest of time. But we also have another one called the content-based filtering. So for the content-based filtering, this one relies on the characteristics of the items and the profiles of user preference. Like for example, uh, they use items like, for example, the keywords, the this word. Let me type here. Someone told me that it is pronounced as genre, but let me just type here so that you can tell me. It usually yes. Not yet. I'm just trying to give a basic overview. Then I'm going to share in a few. So how do you pronounce this word? Someone told me that it's genre. Is it genre or a genre? Yeah, so that I may not, you may not, is it? How do you pronounce it? Someone, any good English person, especially our yeah, gender. Thank you, thank you so much for that. Yeah. So on the content-based filtering, so this one like focuses on the on the item features. Like for example, the category, keywords, and then this one genre or anything. This was not based on the it's not based on the user characteristics. This one is based on the items features. So I think that one provides a basic overview on the recommender system. By the way, we also have the hybrid. Now the hybrid recommender system, this one, this one tries to incorporate the both the what the content and also the collaborative filtering, recommender system. So this one it combines both the collaborative and also content-based filtering techniques. This one can provide more accurate and diverse recommendation, by integrating, multiple sources, for example, based on the users and the items. So, unless there's no question on that basic overview, I think I can share now my screen. Mhm. Let me share my screen and that screen. You can see the screen. Hello. All right. Okay. Okay. All right. So, the assignment was on the recommender system, and so when you just go, I think you are familiar because you did the assignment. I see most people here submitted, so you are familiar about this project. So the idea here was to like implement or create the recommender system, and also they had provided like a walkthrough. I most often miss those sessions, but I watched and I realized that it was quite good, you know, assistance to most people. So it was also provided. So I know you did submit the assignment very well because there's a lot of resources out there to master. So the data you are to access it here. For example, if you are to do it to code like to use the your system operating like to train the models on your system, then you are to download all these all these, basically not all. You could as well download all, but the key thing that I realized. Mhm. My power is gone. See, Wi-Fi hope ijapotea. Sorry guys, I think my power is gone and also Wi-Fi I think it's going to go in a few. But I'm going to switch on my data. But you can hear me. Are you able to hear me? All right. So basically, it's a good practice to explore the data, but the data that we are going to use here basically is just the train data. Now, because this project for me, I decided to use the hybrid. So I used the train data and also the movies because I wanted to incorporate also the content filtering, and I used the genre to it. So you can just click on it, then it's going to download. Alternatively, you could have used the notebook here. But in short, because here we are now working with big data, you need to have a good machine. Otherwise, your system might crash. Your system might crash. Though there's another file, there's another notebook that that can be supported on most computer. I think this one. Let me try to share. So this notebook can run on most operating system. This notebook, like at the implementation here, because I tried to I tried like to reduce and also to split the data such that though it won't be much accurate, but it can be supported on like a most system. But I'm going to explain the project with this code because this one is quite important. Like this is the this one can give you the best result, but also you need to have a good machine. Otherwise, it won't run, it won't work. I know most people were asking me that the other notebook was not working. Basically, this one you need a good computer with good memories for it to work. But the other one will work well, but the result won't be that good. So in this project, we have two files that we are going to use. We have just a second. Sorry for that. So now we have two files that we are going to use. And first of all, because I want to work with the numeric data, remember if you want to train a model now, you need to convert it to numerical data. And the best module to work with the numerical data is NumPy. And then we also have in the, just a second. We are also having pandas. We also have pandas module here. We also have the pandas module here. And then we also have this now, because of this project you realize that it's going to take forever. It's going to take forever to load and for example, just staying there and you don't know what's happening in the background. I decided to use this package. So basically this package allows you to like it allows the notebook to display the progress bar so that you may have some hopes, because it's going to take you forever. And if you don't know like the progress, you can easily give up. But if you see like some percentage there, you can have like some hope that the project is going. In fact, I didn't realize. For me, I began to do the project. I think the last day, I didn't realize that it was quite lengthy. So, but the other notebook, assisted me. But you need to give it time so that it can train the entire, because here we are now working with big data. It's around it's around I think it's around 5 million or so records. So we are beginning by first importing NumPy. So this one is essential for data manipulation and also numerical computation, and also pandas here. The pandas for manipulation, and then this one for what? For I say to display like that progress bar. Then now time to display also the time that it took to, for example, to train like this feature like helps you to see the progress, the time taken, and all that. And then for feature extraction, we use this module from skline. Um, this file, this module, not module, basically is a class, but from this package from sklearn. And then also the surprise module. Now I know this one won't work in most operating system unless you install the Windows build tool, Microsoft. I think let me search for Microsoft build tools. I don't know. Microsoft Visual Studio. And then when you install the Visual Studio, I think it's going to take you a lot of time. you will install the installer, and then you also install the, I think it's is it Windows or something like a desktop build tools for for you to be able to work with the surprise module on your system. Otherwise, you will have to use the Kaggle one because they have the embedded. There you'll be using their resources, not on your system. And in that Kaggle, they already have the surprise module, so you don't need to install. But if you are to use it on your system, basically you need to have the that package, like the Microsoft Visual Studio with the desktop or a Windows build tools for you to be able to install this surprise module and also to be able to work with it. Then here we installed here warnings so that it can ignore the warnings in case we have some depreciation of some modules and all that, so that we may work well with our data. And then we begin by training no by loading the data, and begin by loading the data. And remember, make sure that the files are in the same directory. Otherwise, you have to use the absolute path. To use the relative path, you need to ensure that uh, you need to ensure that it is in the same directory so that you may be able to use it directly. So this code is going to do it. It's going to load this data. We are using now the train data, and also we are using the movies, and also the test. But remember, it's a good practice to explore the data. But for me, I checked before, and this file, it was already cleaned. Like there was no null fields and all that. So it's just a matter of just training the models. But it's a good practice to do the EDA, to explore your data and understand it very well, and also clean it and all those. But this one already it was clean, so it's just for you to train and you know to train your model. So, for example, if I want to view the okay, I'll have to let me. Don't know if it will take time. Let me try to import those modules, and then I don't know if it's going to take long, because I wanted to show you the basic features, so that when I explain there at the bottom, you'll understand what it's going to do. I don't know if it's going to take long. Yeah, so let me view, for example, the head, the twin data set. So these are the features, and on the this one is on the train data set, and then this one is on the test data set. And then also to view if you have the in the event we have the nulls or not. So this file help us to understand this code. Basically, we are using the is null method to, and also to sum the number of nulls in the event we have the nulls in this train mode, and the train data set here, the train data set here. So you realize here there's no work because there are no null values, and they're all numeric values here. So now we are good to work with the to work on this project. So this one is based on the user. But there I forgot, I did not even finish to explain these modules here. Basically here we are using uh, we are using um, we are using both. This is hybrid, like we're using both the content filtering, and also we are using the what we are using the collaborative and also the content based filtering. So now to work on the here we are using this package here basically to work on the to work on the to work on the uh what not content, the other one is the collaborative. We're using that one to work on the with the collaborative filtering, and then also this one, and then also this one is to merge, to put all the algorithms together and be able to work with it. And then Yeah. So basically, the this is CVD plus plus. Basically, we have the CVD. This that one that is the basic, but we have this SVD plus plus. So this one provides more, accurate. It's more advanced compared to the CVD. Remember, you can always find the documentation. There's always a documentation in case you are not familiar about something. You can always find the documentation and learn more about these algorithms. So, and then now, where was I now? So we have everything we've checked, like we don't have the null values, they are all numerics. And now we can do it, we can now try to prepare we can now prepare what? We can now prepare our data. So basically, the reader, the reader is from what? It is from the surprise library. So this one is to define the rating scale for the data set. And then now this, the dataset dot load from method. This one is to convert the pandas data frame into the format suitable for this surprise library. Remember, you can go and learn more about the surprise library. I'm trying to go faster because I also have students that I want to teach in the next few. So, and then here we are trying to perform the hyperparameter tuning because we are working with the big data. We'll not want to use the default default parameters. Remember these packages or these algorithm, they usually have their default parameters with values like hyperparameters. So you need to like adjust in the event you have a lot of data, big data. You need to adjust so that it can work well and give you the best result. Although it's going to take you a lot of time because there's a lot of data and data set, so it's going to take you a lot of time. So basically here, what I did is I just tried to like adjust these hyperparameters. You can always find the documentation. You can always find the documentation on their, like they usually provide the documentation and learn more about this one. I'm trying to go faster. Now, so for this grid search, these are grid search. Basically, this one is used for hyperparameter tuning of the SVD++. This algorithm here. Hmm? Is it? Yeah, SDB++. This is SDB. I don't know. Did I search on the best one? Let me see this documentation. Yeah, by that is the correct documentation that you should learn. So we have these hyperparameters and all that, but we use what we use this grid search module to tune like these module these algorithms to like is used like for tuning those hyperparameters. And then this 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 one is to this contains like this the parameters here so that we are passing here direct instead of like passing all those stuff here because we want to like combine all of them, so we are passing them as a variable here. And then it's going to take you a lot of time, by the way. It's going to take you a lot of time. And then here we are training now the model with this cell. We are trying to train our model, and you can add in the print statement show that it is beginning to train the model. And then when it finishes, you can also add in a statement there to show that training models end, so that you can see it has finished or so or not. So basically, uh, yeah. So basically, uh, this 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 class here, these are we are trying to instantiate this one. Like this one is for getting the best SVD. Remember here we've tuned our hyperparameters here. Now here we are trying to get the best estimator for the model for this SVD plus model to retrieve from the grid search result to get like the best result. And then, this one is this package and also this one is to and train the full the full what the full training set, like, because we have a lot of data, so we wanted to like train all the, by the way you can try to split so that it can not take a lot of time, but this package is going to train like this slope underscore one is going now to like train all the based on all the data sets, and I tell you it's going to take you forever. It's going to, unless you have a good system, it might take you time because we have big data. I checked on that data set, it was I think millions. Then here we are trying to we are fitting like we are trying to fit now the data here now the to our training set. So here we are using this variable training set and to train now the data to train our data, and we are fitting. I think you know guys that this thing we are trying to train the SVDKNN and also the slope one, and then here because it is remember this one is for collaborative filtering, right? So for the content based, here I used the genre. You told me that is genre, so we are using that one, and yeah, and so basically here the implementation here, I don't want to explain the code one by one. I think you have the notebook. So basically this whole cell here is to work on the content base, like and um it's going to like recommend based on the genre. You told me genre. So the first one is going to this method here, this here we are trying to get like the global mean from the training data set, and then here we are trying to get the biases. We are trying to collect like all the biases from the user and also the movies, and then here the ensemble, you understand like the ensemble like to compile all the algorithms, because we have like three algorithms or four. So we are trying to like combine all of them so that we have the one one like you know, one accurate result, because we are using the collaborative and also content based. So we'll try to merge all of them so that it can produce one you know, prediction, one result. So and then here we have here we are trying to like create now the test pairs, and here we are using the user ID and also the movie ID, and also for to get the prediction. Basically here I decided like it goes in batches, like because we have around 5 million. So when you want to iterate on all the 500 5 million. In fact, I'm even stuck to pronounce the name. 5 million records. So it's going to take you forever. So what I did, I decided to like iterate in batches. So the batch size, it is 1,000. 1,000, you can choose to use 10,000 or whichever you wish, but ensure that your machine is good. Otherwise, it might crash because it's going to take a lot of memory. And then so basically here is just the implementation of like iterating in batches, like once the data is iterated, so we want to train like to create now the test pairs. So we are creating but in batches, and then we are saving the prediction. And also here, the same here continues. We are trying to optimize the batch size, because I realize your system can support 1,000. Like for example, when you go with the iteration of 1,000, it can support. There's also another computer that can support 5,000. There's another one that can support 10,000, and also another one that can support 20,000. So I decided like to go like to iterate in batches, like for example, when it tries to iterate in with 5,000 records, and you see the time is good, so it's going to go to the next one. So when it goes to the next one and then perhaps the performance decreases, then it's going to revert back to the previous batch so that it can continue with that one. So the implementation is here. So basically here I've created here a for loop based on the batches. So start time is going to record first of all the start time, and it's going to like to test the like at the prediction, like at the in the event the time in the event, like for example you've the start time, and then it's going to like this one is going to implement like to check on like at the end time. So here we are trying to say in the event the performance on 1000 watt rows was was good. If it was good, then it's going to test the second one. So in the event that the second one wasn't good, then it's going to revert to the first one. Otherwise, it's going to go to the next one, and then the maximum is 20,000. Remember, the increased number of batches will speed up the rate at which it's going to like generate the prediction, but also it's going to use a lot of time. It's going to use a lot of time. Uh, so this one is good. It's going to speed up the rate at which is going to like predict or maybe generate prediction, but also it's going to use a lot of memory on your system. So I decided like to iterate based on the time. Remember, we imported time there at the top to calculate like at the time it's going to take to iterate a particular batch. Like for example, on 1000, if the performance was good, then it's going to test the second one. So it's going to compare in the event the time it took on 1000 was good compared to the second one, then it's going to maintain that one. Otherwise, it's going to shift to the next one until it finds the best optimal batch size that's going to iterate over there. Now we are working with the big data set, so we tried to find like the best way that we can work with it very very well. So by the to work on this project or maybe to create algorithm, basically we need to have good computers. Otherwise, we might get issues. So now the real work is here to generate now the final prediction, to generate like the final prediction. So here is going to do it. Is going to like generate the to generate now prediction, but in batches. Batches, these are like what? These are like the splits. I believe you understand, guys. Batches like the portion, like you split now your data so that it can iterate in bits and then accumulate the prediction, and then remember now the that package that we imported here at the top. This one is going to show the progress. It's going to show us the progress on it's going to show us what it's going to we are using here. So it's going to like display now the progress here. It's going to like give us, because here we are trying to call that function. Remember, we defined that function here, of which is it has like at the time. It's going to take the time to display the progress is taken to like train your model. So you can get like some hops, for example, when it goes from 1% to the second percent and all that until it finishes. So even if it takes days, you can see the progress. Like for me, I always like when I'm working on something, I can see there's a progress. So otherwise, for example, if you are just the computer, like I trained the models behind the scenes and it's taking a day, it's taking 2 days, and I don't know the progress, you might easily give up in that thing that it failed. But I've seen the progress, you can get like some hopes. And then here we are now trying to create like the submission data frame. We are trying to create the submission data frame. So this one is going to convert now the dictionary into now data frame. Remember, the result that is going to generate, or maybe the prediction are going to be in the in key value pairs is going to be like in a dictionary. So now here we are using the this class. We're using like this. We are trying to instantiate. We are trying to use this data frame here now to convert it now to a dictionary so that we can get the result for submission. So this one basically is going to like this data frame is going to do it. Is going to like convert our key value pairs into a data set that we can submit. And the last cell, this one's to create the submission file. So it's going to like convert like the data set that it was generated here. Now the converted key value pairs that was done here is now going to save it to a CSV file so that we can submit. We can submit. I believe I've tried so much to explain. Unless you have a question, guys, though I'm trying to rush because I usually have students that I teach. Do you have a question up to that point? Because I believe, though I've gone too fast, but I think we'll create time in future, and I'll explain these things in details, and in fact also do something to be able to deploy. Do you have a question here based on what we've covered? Anybody? All right. So I believe there's no question. So Lauren, should I return it to you now? I return it to you. Mm.